So g'day and welcome back to Victorian Volcanoes. Today we are at Mount Kororoit and this is pretty much farmland, so you might be able to get to the summit, but I doubt it very much. But on the road you can see up ahead you have the hill is going over the lava flow. Actually all this road is going over the lava flow because this lava flow seems to have some facing south, so this is flowing east. And if we look at the hill, that's west and it's a lot steeper. So here we have Agriculture Victoria. They have Mount Kororoit and they have a description of it. So there's the GPS coordinates if anyone wants to go there. It's cropping. Okay, it's on private land, slopes, grazing, so just have to wait for the cars to pass. Mount Kororoit's a small, asymmetric, conical hill, flattened summit. It doesn't look that flattened. Steep southern slope and a long, gentle north slope. Okay, maybe I have my bearings. Actually, the north slope does look pretty. It doesn't look really steep, it looks about as steep as the east slope. On this flow is a broad swampy depression north of Holden's Road. The hill is predominantly scoria and is capped by rocky outcrops of lava agglomerate. Several narrow create ridges of vesicular basalt, so that's pretty much the top of the lava flow. Prominent on the summit, northern slopes, and suggests a complex internal structure of the volcano. Okay, so it's 237 meters by 60 meters. Blah blah blah, and you've got to have every information about the actual eruption itself. Find an example of a more complex eruption points that occur on the plains of between Melbourne and Woodend. Is unusual scoria cone in its context of the newer volcanics at the late stage of lava flows. Okay, so then you've got some references. Okay, so here's Mount Kororoit. So it's a complex. So the scoria would have come from water percolating down into probably the magma chamber, and then it would have reacted with the lava, caused it to explode and cause some scoria, which is water and gas filled material, and it's like it has lots of vesicles and a lot of it can actually float on water because it's so light with all the gas in it. And then it's got lava flow, so when the water is all being emptied and there's no rain, the lava doesn't interact it. The magma doesn't interact it, and it just so it just forms normal lava. This might have rugby lava, I'm not too sure. So this is the, actually no, I think this is the east face. I got my bearings wrong. So this is the north slope. It's fairly gentle, and around it. So around it we have over there. I believe that is the Black Hills. It's all Ordovician, so I think it's a real sandstone. And so this would have actually been a valley with a watercourse that's been filled. So this is erupted out of the actual plain. Oh, cars are so fucking annoying. Okay, so it's erupted out of the plain and it's filled to form a watercourse. So this would have been a lower depression because, you know, lava likes to flow into the lowest trough that it can actually find. And any watercourses you see around here has been eroded ever since it's been erupted. Okay, so I've gotten off the main road and I'm on the dirt road called Kororoit Creek Road, and this is the southern slope, and it's a lot steeper than the northern slope, which was on the other side. So my bearings were correct. That is the eastern slope, which has the same steepness as the northern slope, and the southern slope is the same steepness as the eastern slope. So the east is that side. And here we have a large mountain range, which will be the Central Highlands. So that would be all different material, but the lava would have actually flowed into the lower depression. So all this plains is just basaltic type of material, and this seems to be a bit reddish. You can see the lava fields, so the material is actually quite red. And over on that side, I'm not too sure what, looks like another caldera, another scoria cone should I say, not a caldera. Scoria cone, it's quite subdued, so it's probably fairly eroded. And all this is pretty much just basalt lava plains. And then we have Melbourne over that way, so I'm not too sure if you can actually see it. So, but we're not talking about that. We're talking about revegetated area. So if we look at the summit, it says a flat top. It doesn't look flat top, it looks conical. So what we can see we have large boulders of basalt. So it looks like there's a large lava flow that can actually come down this way, and that's what we see in the outcrop. But it's been fairly weathered, so that this would not have been the elevation of the volcano probably about 2 to 3 million years ago. It would have probably been a few meters higher, and it's been weathered now. So all that basalt is actually fairly eroded and weathered. So, and because I can't get closer, I can't check to see. I can see it's probably vestibular, but I can't see where the lava flow is and where the actual scoria is. So there would be probably bands of lava flowing over top of scoria, and then scoria erupting over the top of the lava. So they will be fairly distinct. I doubt it very much it would have actually erupted at the same time. So it would be just little bands. And the lava would be a lot tougher than the scoria. So it means that the scoria break down and weather a lot quicker than the lava, because the lava is quite solid, interlocking crystals, and the scoria is just mainly vesicles, so it's pretty much just mainly air inside. So this is Mount Kororoit. If you want to come out and have a look at it, you're quite welcome. You can explore other places around here. So thank you very much. And yeah, pretty much I need to have a shave. I look like a fucking barbarian. Anyway, there's a mountain in the background. Obviously it's got towers, so it does have an access point, but it's also on private land. It's only really good for actually grazing, not cropping, as we see behind me. It looks like there might have been probably wheat. And if you look on the road, you see there's actually mudstone. So this stuff's been imported, it's not local material. So here we have indurinated mudstone, which means that it's leached out probably a lot of the other minerals, other elements, and it's left a lot of iron, which has probably also been brought up during flooding events, and when it's evaporated, it's been precipitated. Along with this is quartz, so you're not going to find quartz in basalt. If you do find quartz in basalt, it would have probably come from another source. Anyway, this is where I'm going to leave the video. Thank you very much. I hope you get a chance to actually come and visit a place like this, because geology is just awesome. But I'm not too sure how deep the actual magma intrusion is, so it actually go down deep into the ground, probably 20 or 30 kilometers. So underneath, it's probably gabbro. I doubt it would have solidified in a 2 million year period. Probably the center of it's still molten, so, but there's no sign of actually volcanoes erupting anytime soon around here. Earthquakes will be the first thing that we'll notice, but they're fairly few and far in between. So obviously this volcanic province, which is the third largest in the world, Western Volcanics, is extinct.